Challenges in hybrid electric vehicles and R&D areas. Main challenges in hybrid electric vehicle design and realization. The main challenges are to be seen into the following points: weight, volume, performance requirements of the vehicle, production and operation cost of the vehicle, technology market penetration. So one has to check these challenges to keep the of the vehicle in optimum or low weight with sufficient volume. Then performance requirement. Now here you can see there is a power and energy requirement and they have their effect on the hybrid electric vehicle design. The key design parameters are shown in this diagram, and these are affected by the power and energy supplying components. We can see the power energy requirement of the vehicle will require for the velocity, uphill performance, aerodynamic drag, ground resistance, mass, and acceleration requirement. Whereas these parameters are determined by the battery, transmission system, thermal management, power tonic system, electric machines, and IC engine. For example, if the maximum range of the vehicle is required here and the required acceleration requirement, we can increase the source rating, that is the battery size and rating. But this will increase the weight and volume of the battery, and in turn, again, it will affect the overall range of the vehicle, and also it will increase the cost. So this is how these parameters are interlinked and optimum solution has to be obtained. So there it may require the best possible optimization programs also. Areas for research and development. Following are few areas for the research and development in hybrid electric vehicle. Design selection and sizing of electric machines. Second important area is the energy storage system. And the last is thermal management system, which are the main areas of research and development in hybrid electric vehicle technology. The first is design, selection, and sizing of the electric machines. There are mainly three electric machine technologies available, such as induction machines, permanent magnet machines, and switched reluctance machines. Due to the extensive operating range, high power torque density, and high power operating efficiency, permanent magnet machines are preferred over the other options for hybrid electric cars. But there is no fixed design category for this type. Permanent magnets show different magnetic properties in different operating temperatures. This has a significant effect on the machine's performance, which is one of the key research area. Machine sizing and selection is not only limited by the propulsive torque, power torque requirement of the vehicle, but also depend on the design process of power converters and electric system. The second area of research and development is the energy storage system. Electrical energy storage system is very critical for hybrid electric vehicle performance. In general, high power and energy dense storage systems are preferred for hybrid electric vehicle applications. Depending on the expected range and required driving cycle, a particular energy storage system will be selected for a particular vehicle. With the increase in electric propulsive components, energy storage requirement also increases. For the safety requirement, nickel metal hydride battery technology is selected by Toyota in their first generation of price. The power and energy density of lithium-ion battery technology appear to be the more attractive. It is becoming the preferred candidate for the auto industry. Extensive research activities are performed to ensure the safe operation of the battery system in various operating conditions. Hybrid energy storage is another promising area of research, that is, the hybrid energy with two or more than two energy sources, which combines the high power dense, for example, supercapacitors and high energy dense electric batteries to provide the various peak power and energy requirement for the vehicle. The supercapacitors are providing the power density, higher power density, and battery can be used to provide the higher energy density. The next research and development area is the thermal management of the electric vehicle, that is a thermal management system. Various propulsive systems in hybrid electric vehicle require different temperature controls for thermal management system design. For example, the coolant temperature requirement of the IC engine is not similar to the coolant temperature requirement for electric machines. In reality, some components are air cooled, some are water cooled, while others are oil cooled. Therefore, the thermal management system needs to be developed to meet all these requirements. In this situation, the thermal management system properly optimize the thermal management system related to the IC engine and management system related to electric drivetrain. This particular attribute to the vehicle demands an adaptive thermal management system designed to handle various driving requirements. This is the one of the challenging area for hybrid electric vehicle technology, that is getting the adaptive thermal management system design.